Alright, another help request for exercise 7.2. Again, the issue is, our equation of interest is equation 7.14. And so in problem 7.2, we're given the pressure drop. We're given L, the length of our section of pipe, diameter of our pipe, density of our fluid, and air, which is air in this case, but we're not given velocity. So in this equation, we have two unknowns, in theory, F and V, okay, but F can be calculated via the Colebrook equation, which is given here. Okay, so the Colebrook equation, pipe roughness is given, so we know the relative roughness. Reynolds number we don't know, okay, but if I look at Reynolds number, the only quantity in my Reynolds number I don't know is V, velocity. So in theory then, the only two variables in this equation that I don't know are F and V. So I can think essentially then that, or I can say essentially then that F is just a function of V, right? F is a function of V. And so up here then, right, yes, I don't know F and V, but F is just a function of V. So essentially the only unknown is V. Okay, so if I set this up as, say, my air function, and then use F0 to systematically iterate on V's until it finds the V that satisfies this equation. For each estimate of V, I'll be able to calculate the Reynolds number with that V. Then once I know Reynolds number for that estimate of V, I can calculate the friction factor, and then use that to estimate or calculate the pressure drop for that estimate of V, and check to see if it is the V that satisfies my equation. Okay, so let's take a look at the code we have. Okay, well, again, let me bring myself with there. Okay, all right, so you can see me drinking coffee in that, like all of you should be, right? Or any good programmer should be. Just kidding. Okay, so let's see. We have a velocity function that takes the pipe roughness as an input. Units aren't clear, but let's see if we can make sense of that. Diameter, guess must be in meters, right? Because it's 4 millimeters. L, rho, mu. Pressure drop, so in kilopascals converted to pascals. Velocity solver. This is good, so they're using an anonymous function, so that the function I'll use in F0 only takes V as an input. That's good. So if you look at V solver, it has, in addition to V, rho, d, mu, dp in pascals. A nice notation. E and L. And then, first thing it does is, well, I've got my, so here's the Colebrook equation from presumably the last problem. So Colebrook has, in addition to F, all those guys as inputs, calculates Reynolds. That's it. So E, the input, must be in meter since D was in meter, so that's dimensionless. So if we have all these inputs going into V solver, here's my anonymous function. I pass them to Colebrook, so Colebrook's only a function of F. And then I solve for F, my friction factor, and then I plug it in, dp minus F times L over D times 1/2 rho V squared. This looks fine to me. I'm not necessarily seeing anything. So let's give it a try. Okay, so let's run it as velocity 7.2. Okay. Okay, and there's even the note 0.26, e to the -3. So error message, F0 cannot continue because function values at the interval endpoints must differ in sign. And this has to deal with velocity. Okay, so the problem must be somewhere because I believe I used brackets of 600 to 300 and it worked just fine. Okay, so let's check over this. Okay, so just to make sure I'm on the right page, I'm going to type that as 4e to the -3. Viscosity is 1.79 times 10 to the -5. Pressure drop Let's look at my V solver. Okay, I'm going to look at this equation first. I'll assume maybe Colebrook's all set from last time. So F times L over D. Okay, and that's L times 1/2 rho V squared. It's looking okay to me. Oh man, this is a tough one. Oh. Aha. Okay. You ready? So, if I look at when I define my anonymous function, look at the order of the variables. V, rho, D, mu, dp, L, and E. I'm going to look at V solver. V, rho, D, mu, dp, E, and L. Right? I have L and E flipped here. Okay, so what I'm passing as L is actually being read in as E, and what I'm passing as E is being assigned to L. So it doesn't matter where I flip it. Let's flip it here. Okay, save it. And rerun. Aha! I got it. All right. Excellent. So all it was is, in general, what I do is when I create a function like this, right, V solver. Okay, I know at the end I'm going to use an anonymous function, so the only unknown variable is V, right, what I'm trying to solve for. Then after that, I'll list all the other variables that I need. And so then when it comes to defining the anonymous function, oftentimes what I'll just do is I'll just copy and paste this up here, right? It's just what I do. So the names of your variables in your helper function need not match that up here, right? As long as these would just need to be the same as names of the variables as defined in your workspace. But I have to make them the same just so I can copy and paste yeah, hopefully try and prevent some issues like that. Okay, so that's it.